Welcome back, class, and hope you are watching my videos. I am receiving WhatsApp messages, so it's good. Today's topic of discussion is oxides of phosphorus. So, this is the lecture number 3. As we had already discussed the oxides of nitrogen in our previous lecture, and then the acidic strength, the relative acidic strength of oxoacids of nitrogen along with some other acids. So here we will talk about the oxides of phosphorus. So the phosphorus, the very first is the P41 one oxygen. Okay, so phosphorus oxide. Then P4O2, then P4O3, P4O4, P4O5, P4O6, P4O7, P408, P409, and P4O10. So out of these 10 oxides of phosphorus, P4O6, which is the dimer of P2O3, and P2O5, P4O10, these two are very important. Okay, P2O5 dimer is P4O10, P2O3 dimer is P4O6. But we will draw the structure of every oxides. So let's start with the very first is P4O. But before that, we will draw the parent structure, the parent P4. So P, then another, then and these are the lone pair. This is, so this is the parent structure of P4. Okay, where one lone pair is there, and then it is bonded with the three other. Okay, then we'll start with the first structure, that is the P4O. So very simple, P, 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 and P. Only what we need to do, we'll put the one oxygen in between this. So this is P4O, and of course the lone pair on the every phosphorus. Then the second P, 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 and P. So now we will put second oxygen. So one oxygen already here, and the second oxygen we will put here. So this is how the lone pair are also on in this oxygen. So this is the P4O2. Then the P4O3. So I think now you can easily draw the structure. P4O3. So P, 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 and P, and one oxygen between these two, one oxygen between these two, and one oxygen between these two. So this is how the so this is P4O3. Next is P4O4. 1, 2, 3, 4. So we will put 4 oxygen. 1, 2, 3, and 4. Then the lone pair at every phosphorus, and the lone pair at every oxygen. So this is what? This is P4O4. Next is P4O5. So P4P, and one oxygen between these, one oxygen between these, one oxygen, one oxygen. Now here one you should remember that the now the fifth oxygen will occupy this position, P or P here, or P or P here. You can put anywhere, not with the double bond. This is very important here. Most of the students makes a mistake. So this is the way, and one of the this PP is there. Okay, and so is the lone pair and the lone pair and oxygen. So this is P4O5. Then the fifth one, P4O6. So 1, 2, 3, and 4. One oxygen, another oxygen, then the another oxygen, then the another oxygen. One oxygen between these two, and other oxygen between these two. Okay. So this is the important one, because as I told you earlier that the P4O6, that is a P2O3 dimer, and P4O, then are the two important structure. Okay, so this is the structure of P4O6. Okay, then the seventh one, sixth one is the P, then P, then another P, then another P. So this is P4O7. So we'll put one oxygen, we will put one oxygen, we will put one oxygen, then we will put one oxygen. This is how. Now the seventh oxygen will occupy with this position, this double bonded. This is the position of seventh with the lone pair. Here lone pair will be out. Okay, and so is the double. So this is the P4O7. Then what's about P4O8? So very simple. 1, 2, 3, and 4. Then the oxygen between P and P. Okay, this oxygen, and one double bond with another one. So this is how the second phosphorus will be occupied, and so is the lone pair. Here only two lone pair on phosphorus is available. Now you can pick other So this is P4O8. Okay, moving ahead, the is P P P P. So one oxygen, one oxygen, one oxygen, one oxygen. Okay, then one. This is the second one, and this is the third one. And here, so this is the structure of P4O9. I think it is very simple to draw this structure. Okay, once you know the basic structure. So this is P4O9, and the last one, that is P4O10. So P, 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 and P. Double bond, double bond, double bond, and double bond. And then the oxygen, oxygen here, oxygen here, oxygen here. This will give, okay, the lone pair, lone pair, lone pair, lone pair. So this is P4O10. Okay, so this is how all four structure will draw. These are the structures of phosphorus oxide, starting from P4O to P410. There are some questions which ask with the which can solve with the help of these structures. Like as I told you earlier, that the out of this structure P4O6, that is, and P4O10 is the important one. So one can ask the number of lone pair. So here the lone pair is available only at oxygen. So lone pair electron in case of P4O10 will be, you can check the lone pair. We have 10 oxygen, so 10 each oxygen containing 4 lone pair electron, 4 electron, so pair will be 20. Okay, 10 containing 20 pair, that means the total electron will be 40. So this is the pair and this is the total electron. Okay, phosphorus do not contain any lone pair of electron here. Then the number of POP bond, this is also sometimes questions are asked, number of POP bond. So POP bond in this case, POP1, POP2, POP3, POP4, POP5 and POP6. So total number of POP bond is 6 in case of this. Similarly, for P4O6 also, the lone pair, so lone pair, each oxygen containing lone pair and each phosphorus also containing a lone pair. So we have 4 phosphorus and 4 oxygen. So lone pair, they can ask question that the total lone pair, and even they can ask the question the what, how many lone pairs at phosphorus or how many lone pair at oxygen. Okay, so here if you go for the calculation, the lone pair at phosphorus. Okay, so in case of phosphorus and in case of oxygen, so lone pair in case of phosphorus 1 2 3 4, so 8 electron. In case of oxygen we have 6 oxygen, so this will be 12. So total is sorry, uh, 1 2 3 4 5 6 12, and phosphorus is 1 2 3 and 4. Okay, so 12 and 8. So here the total, how this you can calculate. Okay, similarly the pop bond, number of POP bond. So POP bond 1, POP bond 2, POP bond 3, POP bond 4, POP bond 5, and POP bond 6. So total number of POP bond will be 6. So this kind of question may also ask. So you should remember that. Okay, so this is the structure, and as I told you that the P2O3 and P2O5, that means P4O6 or P4O10 is an important one, so we'll discuss some of the feature of these two. Okay, so here is P2O3, P4O6, and P2O5 or P4O10. Okay, so let's start the discussion. First thing, P4, that means the very phosphorus combined with oxygen with limited supply. So this will give P4O6 or P2O3. Okay, here P4 oxygen in excess, so this will give P4O10. Okay, second, it is white waxy substance. Okay, and this is white solid. So this is white waxy and this is white solid. And the third is very important, the reaction P2O3 with cold water. Okay, with cold water it will give H3PO3. You can check the reaction balancing. I'm writing, but you can check it. So this is phosphorus acid, orthophosphorus acid sometimes it is also called. We will discuss this in detail in our next lecture. And in this case P4O10 with cold water, this will give HPO, 4HPO. This is called meta phosphorus acid. Meta phosphorus acid. This I will give a detailed information in our next lecture how this meta and ortho will form. Okay, then another reaction for this, again important one, is P2O3 H2O with hot water. So this was with cold water, this is with hot water. So with hot water this will give PH3 and H3PO4. So this was the phosphorus acid, this is phosphoric acid. Phosphoric acid, again the reason is same. Here the oxidant state is +3 and here is the +5 for phosphorus. And the second important reaction for P4O10, that it used as a dehydrating agent. This is important one point to be remember. Dehydrating agent, what does it mean? That means it absorb water. So we will check the reaction. The first reaction is H2SO4. Okay, and if you put P2O5 here, it will absorb water, minus H2O. So what will happen? Minus H2O, so this will give SO3. Similarly, the second one, HNO3. If you put the same P2O5, it will absorb water here, and this is the twice of the molecule. So this will give nitrogen pentoxide. Similarly, in the third case, RCONH2, this will absorb water, so H2 is removed, so it will give RCN cyanide. So this act as a dehydrating agent. So this point you should remember, P4O5. Okay, so at the end, P, this is P, this is P, and this is okay. So and 1 2 lone pair is there. Okay, here what happened in two cases: low concentration of oxygen, and here the high concentration of oxygen. So with the low concentration of oxygen, P, 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 and P, oxygen, then oxygen, then oxygen, then oxygen, then oxygen, and then oxygen. Okay, so with the low concentration of oxygen, what will happen? It will give P4O6. So this is called insertion in pp bond. What will happen here? Every oxygen is come in pp bond. Here one oxygen, here one oxygen, here one oxygen, here one oxygen, here also one oxygen, and here also one oxygen. So this is called insertion in pp bond at a low concentration. Okay, now what happened with the high concentration? So the high concentration, the structure will look like this: P, 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 and P, oxygen, 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 oxygen. So this up to this is level there is no difference, but here the lone pair will be lost. Okay, lone pair of phosphorus. So this is called oxidation of lone pair. This is called oxidation of lone pair. So this is what the difference between these two. The P4 at a low concentration, insertion in pp bond, oxygen insertion in pp bond. At higher concentration, oxidation of lone pair, because here 4 lone pairs are there at phosphorus, but in this case there is no lone pair. Okay, in this case there is no lone pair. So this is what the difference between these two. So this is another important aspect of this P4O6 and P4O10. So this is all about with this lecture. P4O6, P4O10, that is the important one, and this is the structures. These are the structures of all. Thank you so much.